Hello and welcome to MetaMath. In this video, I'm going to be giving a solution to problem 21 from the 2020 AMC8 test. So I'm not going to read the entire problem out loud, but the general idea behind this problem is that we have a point or marker P, and we want to move it to the top at Q, and we can only do this by using left diagonal and right diagonal steps such that we stay on the white tiles at all times. They tell us that we have to go from P to Q and that it's going to be a 7-step path, and we want to find the number of paths that go from P to Q. So one thing that's important to keep in mind here is that we have to use, regardless of what path we take, a total of 3 left steps, and I'm using L here to abbreviate, and 4 right steps. And this should be clear because P is to the left of Q, so in order to get to Q, we have to take at least one more right step than left step to offset that difference. So we'll need a total of 3 left steps and a total of 4 right steps to get from P to Q. And this gives us our 7-step path that we need. Now, to figure out how many paths we can take that satisfy this, we could try to use combinatorics and just do 7 choose 3, which would give us 35. And that is an answer choice. However, the issue with this is that some paths that just follow these rules do not work. For example, if we took 4 rights in a row, we would go off the grid, so we definitely cannot count that in our answer. So one thing we can do instead is simply count the paths just by looking at the grid. So instead of using combinatorics, we can just look at each point that P can go to and then count the number of ways it can get there. So to start off with, P is at this point here, and it can get to each of these points above it in one way, obviously just by moving to it. Now, look at the points above it. So this one, and this one. The number of ways P can get to it is by the sum of the tiles below it. So for this point, there's only one way it can get to it, and that's by taking a right step from here. Similarly, for this point, there's 2 ways because P can go left then right, or right then left. So we have 2 ways, and for the last point on the left, we have 1 point. And we can keep doing this for every white tile above it, as long as it's a possible path that P can take. Now the boundary for P's path is this point right here, because at this point, P has to start going to the right because it's taken 3 left steps. So the boundary for P's paths is along this line. Every other point to the left of it cannot be counted. So now we can just go ahead and fill the rest of the grid. So we have 1 way to get to the leftmost point, and that's just taking 3 lefts in a row. There's 3 ways to get to this point by the sum of the 2 below it. There's 3 ways to get here. There's 3 to get here, 6 to get here, 4 to get here. There's 10 ways to get here, 9 ways to get here, 19 ways to get here, and Q is the sum of the 2 numbers below it, so there's 28 ways to get to Q. So our answer to this problem is going to be A28. Now, if you found this video to be helpful, please consider subscribing and leaving a like. If you have any other topics or problems you'd like to see covered, please go ahead and drop it in the comments. I'll try to make a video on it. Thanks for watching.